Hi everybody, I'm Harshleen Kaur and I'm an educator at Unacademy. You all can also follow me on the Unacademy Learning app and also on the Unacademy Engineering Curriculum YouTube channel and find all my other courses there. So until now we've been studying about all the schema models of a data warehouse. Today we're going to be studying about the second schema model, which is the Snowflake schema, which is a normalized version of the Starflake schema. Let's see that in the further lesson. Hi everybody. Welcome to lesson number 9, that is Snowflake schema, and I am Harshleen Kaur and I am currently working at Gartner as a research associate, and I have been as an educator with Eon Education and I've completed my BTech from Jain University Bangalore, and I was also an ex-NCC cadet with the CSU rank. Okay, so coming to today's topic, which is Snowflake schema. So until now in the previous lessons, we have studied about what a schema is and how a schema is defined, and also about the Starflake schema. So Snowflake schema is nothing but it's a very advanced, or you can say normalized version of a Starflake schema. So as the name itself suggests, snowflaking. Snowflaking is a method of normalizing the dimension tables in a star schema. So by this we mean that both the Snowflake and Starflake schema are very similar, but the only thing is in Snowflake schema the dimensions are normalized into multiple related, they are broken down or normalized into multiple related tables, and in Starflake schema that does not happen. They are just stopped at the first dimension itself, so they are denormalized there, and it in a Starflake schema it's represented only by a single table. So as we would have seen in the Starflake schema, we just had one fact table and we had maybe 4 or 5 dimension tables. But in Snowflake schema, what happens? We have one fact table, we have 4 or 5 dimension tables, and then again we have multiple sub-dimension tables. So that increases the number of tables, yes, but it helps us by normalizing the entire data set. So Starflake and Snowflake schema are most commonly found in dimensional data warehouses and also in data marts, where the speed of data retrieval is more important than the efficiency of the data manipulation. So wherever, because it helps us in faster retrieval of data. So let's see what this term normalization is, or what normalization does in a Starflake schema model. So basically what normalization does is it splits up data into additional tables by moving any commonly repeated groups of data into new tables. So in Starflake schema lesson, we had seen that there was one problem happening, or one drawback of Starflake schema, that was that there is data redundancy formed in that country's example. So here what happens in Snowflake schema, due to normalization, that particular data redundancy is removed by splitting up into into sub-dimension tables. So yes, normalization tends to increase the number of tables that have to be joined, but it also reduces the number of space, the entire space required to hold the data, and the number of places where it has to be updated if ever any data changes take place. And due to normalization in the Snowflake schema, the redundancy is therefore reduced and removed, and it becomes very easy to maintain and also saves the overall storage space, because now it is divided into sub-dimension tables. And how is a Starflake schema better? How is a Snowflake schema better than a Starflake schema? Okay, so here we can see that there are 1 million sales transaction. This is an example wherein 1 million sales transaction are taking place in 200 shops in 220 countries. So overall, in a Starflake, in a star schema, let's take, in a star schema, how much would it be? It would become 1,200,000 records, because in a Starflake schema we would only cover up till here. We would not go into the sub-dimension topic itself, right? So in a Starflake schema we would have 1 million records in the fact table, and then we would have 200 records in the in the dimension tables, where each country would be listed like explicitly for each shop. So here again, remember, we had a problem wherein the country would get repeated. Suppose there are 2 cities in the same country, the country would get repeated. Maybe if there were 2 cities from Canada would be repeated, and that would cause data redundancy, and that would just take up our storage space, right? But that problem is removed in the Snowflake schema. Here what happens, it is more normalized, and here we have country keys referring to the country table. So here again, we would have the same 1 million record fact table, we would have a 200 record shop table, and then we would have another referenced country table with 220 records. So this becomes a very, very simple, and it's normalized our data set. And here what happens is, in this case, the star schema, because star schema, which was denormalized, would reduce the number of records by a factor of almost 0.998, and that factor is obtained by dividing the Starflake schema records by the Snowflake schema records. So in turn, yes, Snowflake schema is better. And okay, so Snowflake schema in detail. So sometimes we have query requirements that are such that business people find Snowflake diagrams easy. And why? Because in Snowflake it is properly divided into sub tables and sub dimension tables, so it's very easy to visualize and understand as well. So for example, the time dimension table, it can be classified further from, firstly, if suppose we have year, it can be broken down into month, then that particular month into a particular day. So this is the first classification. Or suppose if we have week, we can break it down into day, and then maybe from day to time, or we can break it down into quarters, any which way. So this way a dimension time dimension is further broken down. So this gives us a better view, right? So that is why people prefer Snowflake schema. And suppose the time dimension table has a year dimension table, and then it has a month dimension table. So this basically gives us very precise data, and it helps people to calculate the weekly data independently. So this removes redundancy of data. And as you all can see in this particular example, we have a Snowflake schema, and a Snowflake schema basically is a Snowflake schema is in this format. So in the Snowflake schema, we have here is nothing but, so this is how a Snowflake schema is different from a Starflake schema. That is, we have a fact table, then we have further dimension tables, and these further dimension tables are broken down into further sub-dimension tables, as you all can see here and here. So suppose now we understood up to the dimension tables, but after that, suppose in this example, now we have a supplier key. So this supplier key is going to be acting as a foreign key to this supplier dimension table. And here like we have the city key, so the city key is going to be acting as a foreign key to the location dimension table. So this is how it works, wherein it is completely normalized and there is no data redundancy occurring. So it becomes very, very easy to maintain this data set, and therefore also it saves a lot of storage space. And let's take an example of a query using a Snowflake schema. So again, let's consider a database of sales, that is a store chain which is classified according to the date, store, and product. So the first table we make is the fact table. So fact sales table, which has three main dimensions, that is date, store, product. We can name it as dimension underscore date, dimension underscore store. And then as you all can see over here, this is what I was talking about, as we can keep our primary keys and also another attribute which can be used for any kind of aggregate operations. And then we have our dimension tables. We have a dimension tables such as store, product, date, and this further table is broken down. Suppose date is further broken down into day of week, month, quarter, and the product is broken down into brand and product category, and store is broken down into geography. So now this is giving us a very wide idea about the entire data set, and as you all can see, there is no data redundancy occurring. And also how they are referred, I can show it to you. That is, suppose in store we had ID, store number, geography ID. So the geography ID is acting as a foreign key to ID, which is the primary key of geography dimension table. So this is become very easy to understand the entire data set, and there is we can use a very simple query to understand that the number to understand the total number of units that is sold by brand for a particular country in the year 1997. So how this code differs from the Starflake schema model is that, again, we will be using select, and using select we're going to be using b.brand. So b is nothing but the brand dimension tables. So that's p.brand, which is an alias, and then we use g.country because we just need brand, we need country, and then we're going to sum up all the units sold. That was the extra quantity table here. And then from fact underscore sales, we're going to be using inner join to all these particular attributes, that is date, store, geography, product, brand, and product category. So using all of this, we're going to be performing inner join, and then our particular condition comes, which is d.year as 1997, and we're going to be using and. Why? Because we need every product that has been sold in 1997, or every product which has the term TV in it. I mean, which has a category TV, and then we're going to group it by brand and country, and this is how we can calculate all the total number of units sold by either brand or country for a particular year, which is 1997. So this is it for this lesson. Thank you so much. You all can follow me on this link, which is unacademy.com/user/Harsleen Kaur, and you all can also rate, review, and recommend all of these lessons to all your friends or anybody who might be needing it. Thank you so much.